Welcome to Podcast on TechNation. This is a series of podcasts focused specifically on the biomedical and HTM industry. Episodes will be added monthly. Listening to each episode is eligible for 1 CE credit from the ACI. At the conclusion of this episode, you'll be able to access a survey that will appear under this episode's title. You'll be able to download your certificate once you submit the survey. Before we begin today's podcast, I'd like to invite you to our Spring MD Expo. We will be in Temecula, California from April the 15th to the 17th. So please visit mdexposhow.com for event details and registration information. Podcast on TechNation would like to thank our sponsor, Multimedical Systems. Since 1996, Multimedical Systems has provided a comprehensive suite of solutions that help healthcare organizations manage their medical equipment more efficiently, ensuring optimal performance and cost effectiveness. Multimedical Systems specializes in skilled short and long-term temporary biomedical equipment technicians staffing, medical device maintenance and repairs, endoscope and surgical repairs, inventory verifications, and certified pre-owned medical equipment sales. Their promise of quality is highlighted by their achievement of the ISO 13485-2016 International Certification by Orion. For more information, visit multimedicalsystems.com. In this episode, we are joined by Frank Majerowicz, co-founder of FiberTech Medical.
Welcome back to HTM Insider. I'm Sherelle with Multimedical Systems, your host. And today I have on my friend Frank Majerowicz of FiberTech Medical. He's been in the industry a long time. And I think today you're going to learn a lot about endoscopes. And we're going to discuss why a biomed needs to learn about endoscopes and best practice. So this is going to be episode 1 of 2 episodes. So tune in today. And then we'll remind you to tune in again for episode number 2. So, Frank, thank you so much for coming on today. I mean, I know you and I go back, I think, 11-ish years. I've been to your shop. I've enjoyed your company, Jimmy. Your entire team is amazing there at FiberTech. So, without further ado, why don't you introduce yourself to the HTM world out there?
Yeah, thanks, Sherelle. And so hello, HTM world. My name's Frank Majerowicz, and I'm one of the co-founders and still an active partner with a company called FiberTech Medical. I started my career in endoscopes with working for Olympus in the mid-'80s. We started a company called FiberTech in 1989. So we've been in the world of repairing and supporting endoscopes now for 35 years. And so we've seen a lot and learned a lot along the way, and I'm happy to share and answer any advice or insight that I can help with.
And I think it's important to note that when you're working with a endoscope repair company, that they are ISO certified. Do you want to talk about that for a second, Frank?
Yeah, so that is an important question. As many of you may know, there's a lot of endoscope service options in the market today. When we started FiberTech in 1989, that we were one of maybe 2 or 3 companies outside of the OEMs. Today, there might be 40 or 50. And while ISO certification is not a requirement for a third-party service company, it is something that I think should add a level of comfort to any facility or biomed looking for an option. ISO certainly, I think, provides a higher level of comfort that the company you chose is going to be doing things the right way.
Exactly. And if you haven't met me and I haven't taught a class on endoscope best practice on care and handling, maybe I've come to your facility and done a PM inspection on your endoscopes, you got to listen to this because you can affect change in your facilities and your departments and save money. So today we're really going to focus on educating you first on a general flexible endoscope and its parts. So you're familiar with the vernacular and how this endoscope works. So that's our focus today. So Frank, I want you to show, I know you have a scope there for us to
Mhm.
see. What do you have in front of you today?
Yeah, so today I think we'll talk about the basics, and you're right, Sherelle. To many people in biomeds, and it's like a black box. Okay, you're familiar with the outside of it. You may be comfortable holding it and picking it up, or you may not be yet. But I think what's going to be helpful today is we'll talk about some of the common issues that occur with scopes, show you some of the common components, and give you a much better understanding, and hopefully you'll feel more comfortable next time you have to pick one up. So in front of us today, I do have a full colonoscope sitting here in front of me that we'll reference at some point during this conversation. We have a bending section, which we'll talk about shortly. We have the outer cover of that, the bending rubber we'll take a look at. I have a channel in front of us, a damaged one at that, and the CCD and a couple other small parts sitting here as well. Okay.
Let's talk about how long is a colonoscope.
Oh, you're really testing my 30 years of experience here on that one. So let's just say it's about 6 foot long.
Yes, 6 foot long. So it's
Yeah.
very important, technicians, when you're out there and you're handling these endoscopes, they're very delicate. And when you hear about the price of what these endoscopes cost new, usually it's more than most vehicles out there. So you want to handle them with care, and you want to know how to handle these endoscopes. And a 6 foot long colonoscope, the insertion tube can get away from you if not managed and handled correctly. So I'm 5'5". If I held it up, it's longer than myself. Okay, just take that into consideration. And that's just insertion tube. That's not the rest of the endoscope. So, Frank, let's just start with the control body of the endoscope. Can you tell us the names of each part of the control body and what their function is?
Yeah, absolutely. And to add to a comment you just made, Sherelle, um, let's talk about cost for a minute. So the average endoscope now, brand new, is $35 to $40,000 for a brand new endoscope. And you're right; it's about the price of it used to be the price of a car. Now I don't know if
Right.
you can buy a car for $35,000, but maybe a nice used one. But um, yeah, so you're looking at 35, 40 plus $1,000 for a brand new scope. And the average repair cost, it's not uncommon that one of these scopes goes back to Olympus or the OEM, and you could be looking at a $10,000 to $12,000 repair for just one repair incident. Our average repair at FiberTech is even $2,500. That's the average repair. So, very costly device to repair, very fragile instrument. And the more that you can learn how to take better care of them, how to handle them, and how to prevent that damage, it can be a pretty substantial impact to the facility that you find yourself at. So, to that point, what we're holding here is a an Olympus colonoscope. Okay, so just to go over a little bit of nomenclature. So when you hear anybody referring to a scope, this is called the control body. Okay, so this is called the control body of the scope, where the physician will grip the scope to maneuver it. These are going to be your angulation knobs. Okay, they call these the angulation control knobs. On a standard colonoscope and gastroscope, you're going to have two big knobs at the top. One's going to be right and left. One's going to articulate the tip up and down. Okay. On some of your smaller scopes, Sherrill, like a bronchoscope or a ureteroscope, they're only going to have a lever because their angulation capability is only two-way, up and down. Whereas, again, a colonoscope and a gastroscope is going to have four-way angulation with two knobs.
Can you show the end, Frank, so they can understand what the angulation is, the tip of the
Absolutely.
colonoscope, and show them how when you're doing up, down, right, left, how
Yep,
it.
absolutely. So if we come back to this, we have the control knobs that we just spoke about. And then this is the other end of the scope. You're looking at the distal end of the scope. This is not what you will see in the field. This has the outer sheath peeled back some. So at some point in the conversation, we might talk about what's underneath that black box, if you will. But as you can see here, as I turn one of these control knobs, this tip will articulate. Okay. So that's going to be up. And we turn the knob the other way, and you're going to go down. Okay. And then, of course, right and left. So you have good control. With that control, with this functionality comes problems. So we'll talk about those shortly.
Yeah, and you know, been doing this a little while, as you know. There's a little lever up there that's on top of the angulation knobs. And let's talk about that because I've seen it so many times. And if you don't know about this little lever, you can do damage to the endoscope. So we've got to make sure that you have this lever in the correct position. Frank, you want to show that one?
Yeah, so right up at the top of the scope, back to the control body, back to the control knobs. Right above the control knob is a lever. It's called the locking mechanism. Okay, you will see an F on there with an arrow. That F stands for free. Okay, so if you slide this over to the free position, that's telling you that the knobs are free and the tip will turn freely when you angulate it. If I were to angulate this scope and pull this lever back to the other side, that locks the knob. Okay, so now you can see the tip did not move. Okay, we're locked in. Okay, now that's helpful during a procedure. If the physician is in the colon, he's in a certain position, he wants to lock in so he doesn't lose his spot or lose what he's focused in on, he can lock that knob and the tip will stay there when he takes his hand off the control knob. However, when not in a procedure and the scope is just in your hands or in the closet or being cleaned, you never want this to be locked. You want this to be free so the tip will move freely when you articulate things. Okay. If not, as Sherelle had mentioned, alluded to, it can cause some damage. If this is locked and you try to angulate this or move this with your hands, you're putting extra stress on the cables, the inner components of the scope. It's just not good for the scope. So first thing is always make sure that these are in the unlocked position and this is freely moving. Okay.
I like to equate it to having your emergency brake on. We put our emergency brake on. If you really hit the gas, how you can go forward, you can eventually go forward, but have you done internal damage? And since you can't see inside that endoscope, you don't know. All you're going to know is maybe it's not functioning correctly. And that could be the cause of it. So that's very important for you to know, especially if you get involved in doing preventative maintenance inspections on these endoscopes. So Frank, you want to show the channels there, like all the little, it looks like where you could put something in?
Yeah, so absolutely. So I think we'll start. So if we just talk about the nomenclature of the scope and some of the common components, we already talked about the control body, the angulation control knobs, and the locks. At the very top of the scope, we call this the control head, okay? And if you look up there, you're going to have 4 different buttons. Now, depending on what kind of scope it is, usually it's 4, sometimes there may be 5 buttons up there. These buttons are programmable so that during the procedure, the physician can program and utilize these buttons to activate different features of the scope. One of them is always used to freeze the image on the screen. One of them is always used to take a picture, okay, during the procedure. The other ones can be programmed to do a variety of different functions that the scope has the capability to do. So keep in mind, one button will always be freezing a picture, one will always be taking the picture, and typically the other buttons are programmed to the preference of the facility or the preference of the physician using the scope. Okay, so again, this is called the control body and the control head of the scope. As we go on down the scope, right below the control body, you lead into the insertion tube. Okay, so again, as we mentioned in the beginning, the insertion tube on a colonoscope is nearly 6 foot long. Okay, at the end of the insertion tube, you have the portion of the scope which we call the bending section. Obviously, it's called the bending section because it bends. It just makes sense. So this is the bending section area of the scope. And at the very tip, we call this the distal tip. This is the distal tip of the scope. Not sure if you can get a good view here, a little bit, but you can see at the distal tip, you have a large opening, which is the opening of the biopsy channel. That is a multi-purpose channel opening here. It's used for suctioning. So it's your suction channel, and is also the biopsy channel. So when an instrument is inserted into the scope from the head of the scope, this is where that instrument will come out. Instrument being, in most cases, a grasper or a biopsy forceps. Also at the distal tip, you can see a series of lenses at the very tip. One of those is going to be the camera. The one in this, the large lens in the center is the camera. And then flanking both sides of that center lens are going to be your lights. We call those the light guide lens. Okay. And then that silver mushroom or silver dot you see at the end, on some of the newer scopes, that's black and not silver, but that's going to be your air water nozzle. And the purpose of that component, there's actually, you can't see it here, but there's an opening on one side of that nozzle. And the purpose of that is to flush air and water over the lens and over the camera lens. Obviously, that lens gets dirty during a procedure, and you need to have the ability to keep that clean throughout the procedure.
Delicate is that end of that endoscope there.
Yeah, so when you talk about some of the common damage to an endoscope and really what to be careful with, this section of the scope, I usually say this is your most delicate part of the scope, okay? The tip of it is made out of a plastic material. The lenses are made out of glass. And keep in mind, again, back to the 6-foot long tube, if it slips out of your hand, it makes it to the floor, you're going to hear this as it hits the floor. And many scopes come in with cracked lenses. Many scopes come in with this black cap at the tip cracked. And it's just a common thing that we see, and it's preventable. It's simply from the tip of the scope hitting the countertop or hitting the floor accidentally, causing those cracks.
You want to explain what the numbers are on the insertion tube?
Yeah, the numbers are important during the procedure. Okay, so it basically marks the centimeters of the scope. Okay, as it goes down the tube, and it allows the physician during a procedure basically to know how far he's in the colon. Okay, so it's just a marking measurement reference for the physician during the case, and he can it gives him a good idea as to where he is in the procedure and how far into the colon the scope might be. I'm going to go back to the distal tip here again with you, Sherelle. So when you pick up a scope in the field, I mentioned earlier that a portion of this is already taken apart. This is what we call the bending rubber. The bending rubber is a thin rubber material, and it covers the outer 5 or 6 inches of the scope. So when you pick up the scope in the field, you're not going to see the silver colored distal end here. That's going to be covered by this sheath, just like you see here. This sheath is very fragile because it's thin, and it needs to be thin because if you put something on the tip that was thick, it would reduce the flexibility of the distal tip. So because of that, by the design of the scope, we're stuck having to put this thin outer sheath on there. This sheath is very prone to getting cuts, nicks, holes in it, and leaks in it. So during the leak test procedure that every facility should be doing after every case, this is a common area of the scope that they will find an external leak. Okay.
And one of the reasons, Frank, tell them why the angulation and where it comes from, because of passing the sharp instrument when the scope is fully angulated.
Yeah. So, well, there's many reasons why you can get a leak in this outer sheath. It could be a sharp fingernail. It could be the scope was put in the sink with some other sharp instruments. It could be this tip dragged across the countertop or hit the floor. A lot of different ways that you can get a leak in this outer sheath. Um, One thing to keep in mind, and I don't think we're going to spend a lot of time on leak testing on this particular episode, but when you're leak testing or when the user is leak testing the scope, you do want to angulate the tip like this in all 4 directions, okay? And the reason you want to do that is because this is a rubber material, and so many times you might have a pinhole in this rubber sheath, and if you just keep this distal end straight like this, you don't see the leak, okay? And not until you angulate it will you stretch the rubber, open up the hole, expose the leak, and then you'll start to see the leak. Okay. So many leaks and pinholes are missed because of improper leak testing and not angulating that tip. So that angulation in all four directions is a very important step, not to be missed when they're performing the leak test.
And when they're looking at the bending rubber bending section, the epoxy seals, if they're going to do a preventative maintenance inspection, when the seals start to turn gray, opaque, there's chips in the epoxies, there's anything that they could, visually see on the outside, should it go in for repair?
Yeah, so that's a really good question that a lot of people don't understand. So again, right here, the seal on the top of this is missing because the bending rubber's been cut off. Okay, but if you look at the bottom here, you can see a shiny, just a small, about the size of my finger here. Okay, so when this bending sheath is put onto the scope, um, to help hold it in place and secure it to the scope, there's an adhesive ring at the bottom and there's an adhesive ring at the top. Okay, when those adhesive rings are brand new, like this one, you can see it's nice, black and shiny, almost matches the look and texture of the insertion tube itself. What happens to that is both of these adhesive seals over time, just from the routine cleaning of the scope, the chemicals that the scope is subjected to during the cleaning process, and just the manipulation of the tube and the distal tip, over time, those adhesives will break down. Okay. And they break down in a series of progression. Okay. The first thing that usually happens is from the chemical solutions, they'll start to turn gray. They'll start to look discolored. They'll start to look gray. Um, a gray glue joint or a gray adhesive seal, um, that by itself is not an immediate reason to send it in for repair, but it is a sign. It is a sign for the user that the seals are starting to wear. Okay, what you want to look for is if they start to become brittle, if the adhesive joint sealant starts to become brittle, and if it starts to chip, or if it starts to lift away from the insertion tube or the bending rubber. Okay. So again, a discolored gray seal by itself um, is not a reason to send the scope in immediately to have that replaced. But again, it is stage one of that adhesive starting to wear and starting to break down. What you want to do when you see that is you want to take a closer look. I recommend all of our customers to have a magnifying glass, whether it be an eye loupe or a reading magnifying glass, that they can get a close-up view, magnified view of these adhesives, and see if there's any chipping of the edges, or see if the edges are starting to lift away from the tube itself. Now, when you see that, that's when it's critical that this gets sent in for repair. You want to have those seals replaced, one, before they start leaking and open up the potential risk of fluid intrusion and a much larger repair. But two, when you start to see the lifting and the chipping of those, it could become a cleaning hazard. It's a hidden areas where bacteria can get, and it's going to make it difficult for those areas to be cleaned. Okay.
Yep, 100%. So before we move on to anything else, I want you to talk about how fragile, even though it looks like a garden hose, let's talk about the glass that's inside a flexible endoscope.
Yeah. So inside of the scope, I think you might be referring your question to the light guide fibers.
Right. Exactly. But I just wanted I wanted
Yeah.
you to tell the audience, Frank.
Yeah. Okay. All
Because I
right.
want you to know
So
how delicate it is, even though it looks similar to a garden hose,
yeah.
and all the components inside it, how delicate they are, especially the light guide fibers.
Yeah. So absolutely. So um, and that's a good discussion point. So Cheryl is correct. When you hold a scope in your hand, okay, you hold this. It's called an insertion tube, but you can refer to it as a garden hose. It feels pretty sturdy. Okay, it feels like this can be flexed and take a lot. But keep in mind, what you don't see is on the inside of this tube. There's real estate is limited inside this tube. There's a biopsy suction channel. There's an air channel. There's a water channel. There are wires in there. There are sometimes an auxiliary water channel in there. There are fiber bundles in there, glass fiber bundles that distribute the light from one end of the scope coming out of the light source back to the tip of the scope at the end of the insertion tube here. So there's a lot of components packed in this tube, and there's really not any extra space. So what that means is if you overcoil the scope, okay, if you coil this too tightly right now, it looks like this tube can handle this, but keep in mind you're putting a lot of pressure on all those components that are inside of this tube. They're going to wear out faster if you routinely do something like this, or they could be damaged from one event like this of overcoiling the scope. The other thing to keep in mind is if the outer tube here is kinked, if it's stepped on, we've seen carts roll over these tubes and they get dented. Okay. We've seen a common area for these tubes to kink are up at the top of the insertion tube, right before it leads into the body, because during a procedure, the physician is holding the control handle up here, manipulating the knobs with his hand, but he's also maneuvering the scope back and forth, trying to navigate it through the colon. And as this is occurring, it's putting a lot of pressure on the insertion tube right here before it connects into this control body. And oftentimes when you see scopes hanging in the closet, you might see kinks. We call them buckles, but you might see a buckle or a kink at the top of the insertion tube right below the boot before it goes into this body. And that's a sign that the outer tube is wearing, it's breaking down, and it's kinked. And what's going to happen is these dents and crushes and buckles in the tube, they all eventually, maybe not right away, but they will all eventually affect the inner components of the scope as well. Okay. And one of those inner components that we just started talking about is what we call the light guide fiber bundle. So the way the light travels through an endoscope is basically old-fashioned fiber optics. Okay, it's a fiber optic strand of light fibers made out of glass. There's several thousand fibers, all spun together in a bundle, and they connect from the distal tip of the scope all the way back to the connector. So this is the connector of a 180 scope. But the 190 scope is a different connector, but the internal mechanics are the same. This is the connector that plugs into the light source, okay? So that fiber bundle will start here, that goes into the light source and run all the way through the scope. So as time goes by, those light fibers, Cheryl, will start to break. Even from normal usage, in a perfect world, after the scope's been used several hundred times, all the flexing and twisting and manipulating the tube of the scope, those glass fibers will naturally start to break. So your light output will over time just reduce from 100% output down, okay? And down to a point where it'll be noticeable during a procedure, noticeable on the screen that the scope looks dim. And oftentimes, when the image on the screen looks dim, that's typically an indication that light fiber, there's enough fibers broken that the light's not getting through. Okay.
So you guys, do you hear that? What he's saying when you're getting a call that something's wrong with the light source, the processor, and this could be in several different type of endoscopes. There's things that could be going on with the scope that have nothing to do with the tower itself. It's not suctioning. The water's not working. We have bad lighting. You're going to get those complaints to the biomed shop. Hey, I need you to come look at this. It could be that scope. So don't always take it as the tower is in trouble. Maybe try a different scope and see if you're getting the same result. But he has an insertion tube there that could show you a kink. When he's showing you the kinks on that endoscope, that's kind of like trying to suck through a straw that you bent and you can't suck through it correctly, or you can't push things through it correctly. So just, look at the scope that when you get the call, when you get into the endoscopy suite, and look at that physical scope. Do you see buckling? Do you see damage to that endoscope? And then you can look at your tower and see if there's a problem there. Don't you think, Frank? Would you agree?
Yeah, absolutely. And then here is actually, this is the fiber optic bundle we were just talking about. Okay, so you can see how these fibers are wound together inside this bundle. But when you look at the end and you cut it off, all of these are individual glass hairs. Okay, and if there's one break, if there's a break in one hair, keep in mind this bundle is now 12 feet long because the insertion tube is 6 foot and the U cord that connects behind the scope back to the processor is another 6 foot. So this is 12 foot long. So each glass strand here is a solid connection from one end to the other end. And as one hair breaks, okay, the light can't get by. Now, in reality, it would take at least 20 to 30% of these to break before the light will start to get dim. Okay, dim to a point where it's going to affect the procedure. But once you start to get beyond 20% breakage, um, people, physicians, the staff will typically start to notice the light getting dim, the image looking a little dim. And as Sherelle mentioned, it was a good point. So if you're called into a room or if somebody in your facility is complaining that the scope looks dim, the first thing to do, obviously, is to check the scope in another room. Okay, let's make sure it's not the bulb. Let's make sure it's not a setting on the light source that's creating that dimness. So the first thing I would do is plug in another scope. If another scope looks bright enough, then that's your first indicator that it might not be the processor or the light source. It might be something wrong with the scope. Okay. So there is a series of things that, troubleshooting steps that you can go through before you call a service company or before you ship the scope out for repair. Let's move the scope to another room, plug in another scope. Let's make sure that it is indeed the scope and not a setting on the light source or the processor that was accidentally set to the wrong setting. Okay.
I think you and I could talk scopes all day long, Frank.
We could talk for 3 hours. We could talk for an entire day here.
I think
We try to
it's
keep it as interesting as possible.
Oh, I think it is interesting. And every time that I've gone into a biomed shop and I do like an in-service training or take somebody along to do a preventative maintenance inspection on their fleet, I know that the biomeds out there, they want to learn. They want more information. They want to affect, patient care and patient safety and reduce cost. So this is just the beginning of our endoscope discussion. And this is just flexible. We're just talking colonoscopes today. There's, GI scopes. There's urology scopes. There's so many. We haven't even gotten to the scopes that are in surgery yet. So I know the half hour has gone by super fast today, and we hope that you've really enjoyed it. And I always enjoy getting with you, Frank. We end every episode with a wow, your word or words of wisdom. So we're hanging on the edge of our seat, Frank. What is your wow today?
Oh, my wow today is it's a reactive world, right? And oftentimes the challenge that I think a biomed has, or the challenge that an endoscope repair company has, including the OEMs, is that when a scope breaks, everybody's in a panic. Okay. And they usually break on a Monday morning when they have Tuesday's a busy day. We need a loaner. We don't have enough scopes. The doctors are yelling because we're waiting too long because 2 scopes are broken. And um, that's because it's a reactive world. It's a reactive scenario. And I think that by having a better understanding of the scopes, by learning how to inspect the scopes, okay, we can hopefully limit those reactive scenarios and become more proactive and reduce those Monday morning headaches where there's not enough scopes in the closet because there too many are broken.
100%. And what we're going to try to do through these episodes on endoscopy training overall is to give you the education that you might have not received before. And so you can be a better steward of the equipment. And when you go in there, you have an education and a background of how to troubleshoot. We'll also list Frank's information because I know Frank and his team are always available if you have any questions or if you want to know more information. Maybe you're interested in even having, someone come out to your facility and do some endoscopy training. I know the FiberTech team is amazing and they'd be happy to do so. My word of wisdom for this episode is treat every endoscope as if it's dirty.
That's
A
good.
broken scope doesn't always get the full HLD, high level disinfection, done to it properly. So always wear gloves. Every endoscope is dirty. That colonoscope goes you know where. And so protect yourself, your work desk, and your workplace as well. So thanks for joining us again on HTM Insider. Frank, it's been a joy having you on this first episode. And make sure you share this with your friends. You can find us any place that you listen to your podcast, Spotify, Apple Music, YouTube. And of course, if you listen on TechNation, every episode that you listen to of HTM Insider is worth 1 CE credit. So thanks again for tuning in. And Frank, I will catch you on the next episode.
Thank you, Sherelle. Okay, bye-bye.
Thank you.
Thank you for a great presentation. If you enjoyed today's episode, you might enjoy our ongoing webinar series, Webinar Wednesday. You can find a calendar of upcoming live webinars, as well as an archive of on-demand webinars at webinarwednesday.live. To obtain your certificate for 1 CE credit from the ACI, please remember to complete and submit the survey located below the podcast title. If you have any questions, you can reach us at webinar@mdpublishing.com.